Show by counterexample that the statement cos cubed theta is equivalent to 1 minus sine cubed theta is false. Write down a value of theta which does satisfy the equation cos cubed theta equals 1 minus sine cubed theta. Find all the values of theta in the range of theta between 0 and 360 degrees, satisfying this equation here. Okay then, let's have a look at this then. I've got the question summary form here. Okay, part 1 then. A counterexample, so we need a value. If we put 0 in, we get 1 here. If we put 0 in, we'd get 0, and that would be 1. So that would be suitable for this. But if we put theta is pi over 2, then we'd get cos 90 cubed, which is 0, and that would be 0. But if we put theta is equal to 180, because I think the signs hopefully will do something there. So theta equals pi. Working in degrees in the second part, so I'm going to write it in degrees. 180 degrees gives, let's have a look at this one then. Cos of 180 cubed is minus 1 cubed, isn't it? Cos 180 is minus 1. 1 minus sine, let's just write the value. Sine theta, sine of 180 is 0, and that would be cubed. So minus 1 is equivalent to 1. So theta equals 180 degrees is just such a value. Okay, part 2, write down a value of theta which does satisfy the equation. So part 2, theta equals 0 then, gives, cos 0 cubed is 1 cubed, is 1 minus sine 0 cubed, which equals 1, and 1 equals that. So theta equals 0. Now part B. Solve this equation then. Cos x squared cot, so we'll need the trigonometric formula. Sine squared plus cos squared equals 1. So divide by, we need cot squared, don't we? So divide by sine squared, we get 1 plus sine squared is cot squared, and this is cos x squared. So we can replace cos x squared by 1 plus cot squared, and we can obtain a quadratic in cot. So here, 4 lots of cos x squared is 1 plus cot squared is equal to the 9 minus 8 cot theta. So expand the bracket, 4 plus 4 cot squared then is equal to 9 minus 8 cot theta. Okay, let's get everything on one side. The 4 cot squared can stay as is. Move the minus 8 to become plus 8 cot theta, and then move the 9 over to be minus 9. 4 take 9 is minus 5. Now we know it's 5 ones, it has to be 5 ones if it factorizes. 2 2's would give a difference of 8, wouldn't it? If we put 2 cot theta here and 2 cot theta, we'll have a 10 and a 2, and the difference is 8. So if we make this plus because it's bigger, and that being plus, and this minus, that should do. So this one gives 4 cot squared minus 10 plus 10 minus 2 cot theta, which is our 8 cot theta. Minus times plus is a minus. 1 times 5 is 5, so that's fine. This one tells us that cot theta is a half, doesn't it? So tan theta is 2. So write that down straight away. And this one says cot theta is minus 5 over 2. So tan theta is equal to minus 2/5. So let's just double check that. This one says cot theta is a half. So tan theta is 2 then. Invert the fraction. Cot theta is minus 5/2. So tan theta will be minus 2/5. That's it. This is now a standard thing. Draw a circle. We're solving from 0 to 360. Right cast. Tan is positive here and here. Draw 2 lines. Mark off the alpha, the associated acute angle, and simply write tan alpha is equal to 2. So then we can work out alpha, shift tan alpha. We're in degrees mode, so shift tan of 2. 63.43, so 63.4 will do. 63.4 then. So theta is equal to then, the first solution will be around to here, 63.4 degrees, and the next solution will be around to here, 180 plus 63, 243.4 degrees. So there's our first one then. Now the next one, again draw a circle, right cast. Tan is positive here and here, so it's negative there and there. So tan is negative. Draw 2 lines and mark off alpha, the associated acute angle, to the horizontal. And write tan alpha and drop the negative if there is one to drop. Alpha is shift tan 0.4, isn't it? So let's do that then. Shift tan 0.4. 21.8 degrees. So there's alpha. Theta then, in this case, is equal to, well, the first solution will be round to here. 180 back 21.8, which is 158.2. And the next solution will be right around to here. 360 back 21.8, which is 338.2 degrees. And there's our solutions for theta.